In this lecture, we discuss one application of integrals. This application is about finding area between two curves. So imagine that you have two functions f and g, and the curves of f and g look like this. This is the curve of f of x, and this is the curve of g of x. And this point here is A, this point is B. And we want to find area between those two curves, this area. Now, as we can see, this area is bounded above, this area is bounded above by the function f and bounded below by the function g. Now, how to find the area between those two curves? Here we apply integral. So area is equal to the integral from a to b of f of x, the upper function, minus the lower function g of x dx. So we use this formula. F of x is the top function and g of x is the bottom function. So this formula should give us that area between a and or function f of x and function g of x from a to b, from x equals a to x equals b. Now let's take some examples. For example, if we want to find the area between the two curves of f of x equals negative x squared minus 3x plus 4 and g of x is equal to x squared minus 3x minus 4 between x equals negative 1 and x equals 1. Now we want to find the area between those two curves from x equals 1 to x equals minus 1 to x equals 1. Now you can graph the function. If you can graph the functions, it becomes easier to find the area, but that's not necessary. So how to know that this is not necessary? Look at the first function, f of x. For the function f of x, as you can see, the coefficient of x squared is negative, and that means this is a parabola that's open down. And for the second function, this is a quadratic function with positive leading coefficient. I mean the coefficient of x squared is positive. That means it's open up. Now, to make sure that they do not intersect between negative 1 and 1, because sometimes this is above this here, but then they change. Now here this is f, this is g. In this interval, f is above g, and this interval g is above f. So we want to make sure that this point does not exist. We don't have another intersection. So what should we do in this case? We take the right hand side of each function and make them equal to each other. Negative x squared minus 3x plus 4 is equal to x squared minus 3x minus 4. We want to find the points in common. If we don't have any point in common, that means we just integrate from negative 1 to 1 of f of x, because it's open down, that means it's the maximum, minus g of x, that's open from below, or open up, that's the below, or the bound of the function, or the area from below. Now we set these equal to each other. Now we add x squared to both sides. This becomes 0. We get negative 3x plus 4 equals 2x squared minus 3x minus 4. And then we add, as we can see, we can add 3x to both sides. These cancel out, and we get 4 equals 2x squared minus 4 then we add 4. We are solving for x squared. That means 2x squared is equal to 4 plus 4, which is 8. Then we divide by 2. X squared is equals 4. That means x equals plus or minus 2. But as you can see, the interval that we have here is -1 to 1. But 2 and -2 are points here. -2 and 2. Those are out of this interval. So we don't need to worry about this. What does that mean? That means the function, the above or the top function is f and the bottom function is g. So what is the area? The area is the integral from -1 to 1 of f of x minus g of x dx. Now this is -1 to 1. F of x equals -x squared minus 3x plus 4 minus g of x. G of x is x squared minus 3x minus 4 dx. And then we simplify the integrand, I mean this function. We have -x squared minus 3x plus 4, and then we insert the negative sign to this expression. -x squared plus 3x plus 4 dx. Now we have -x squared, -x squared, that's -2x squared, -3x squared plus 3x squared, that's 0. 4 plus 4 is 8 now dx. And then we integrate. What is integral of -2x squared? It's -2x cubed over 3. We add 1 to the power using the power rule of the integrals. Plus 8. 8 becomes 8x because it's just a constant. And then we integrate from -1 to 1. Now we plug the upper limit of the integral. We get -2/3 plus 8 minus, substitute the lower limit. When we substitute -1 here, it's still -1 because this is cubed. -1 times -2 is +2 over 3. 8 times -1, -8. Now we try to get a common denominator here and here. So we have 24 minus 2, 22 over 3 minus. And here we have 2 minus 24, which is -22 over 3. Negative becomes positive, so the area is 44 over 3 units, or units squared. Now another example. We want to find the area between the functions f of x, the curves of f of x equals 3x squared and g of x equals 1 minus x squared. And you need to understand if this is y and this is y, that's okay. Those are two different functions. Sometimes we denote f of x y and g of x y as well. So don't worry about this. Now we have two functions, and the area we want to apply the integral from x equals 0 to x equals 1. Okay, so same idea. Now by the way, if we want to graph this function, if we want to graph this function, the given function, the graph looks like this. And as I mentioned, it's a good idea to graph the function if we can graph it, and we don't need to get an accurate graph, just a rough graph to determine which function is above, is the top function, and which function is below function. For example, here 3x squared, the graph looks like this. This is 3x squared, and 1 minus x squared, as you can see, the sign of x squared is negative. That means it's open down. Now when x equals 0, this function becomes positive 1, and when x equals 1 or -1, these are the intercepts, the x-intercept. So the graph looks like this. The area is this area. It's between 0 and 1. So the area is here and here, up to 1. So up to x equals 1. But if we don't want to graph the function, that's fine. So what should we do? Now this point here is 1/2. Now if we don't want, so what we want to do is to add this area to this area. That gives us the required area. Now if we don't want to graph, we can just set them equal to each other. We have 3x squared equals 1 minus x squared, and then we can add x squared to both sides. This becomes 0. We have 4x squared equals 1, and then divide by the coefficient of x squared. Then take the square root of both sides. We get positive negative 1/2, plus or minus 1/2. Now, but the interval that we are given here is 0 to 1, and -1 is here. -1 is here. -1/2. This does not belong to the interval. We don't need to worry about it. But positive 1/2 is here. It's the midway between 0 and 1. So that means the function will change. As you can see from the graph, the function here is above, then becomes below. And here this 3x squared becomes the upper function. By the way, this function is 1 minus x squared. So what should we do in this case? Now we just choose, that means this point changes the function who's in the top and the function who's in the bottom. So we can try some value here between 1/2 and 1. Let's choose 3/4, and a value between 0 and 1/2. Let's choose 1/4, and substitute them in each of the functions to see which one is larger. So let's start with 3/4. So when we substitute 3/4 in f of 3/4 is 3 times 3/4 squared, and that's 3 times 9/16, 27/16. This is f. What about g? G of 3/4 is 1 minus x squared, which is 9/16. Now get a common denominator, multiply by 16. 16 minus 9 is 7/16. And as we can see, 27/16 is larger than 7/16. So that means the top is f and the bottom is g. So that means on this interval, f minus g. Now between 0 and 1/2, we try 1/4. So f of 1/4 is 3 times x squared, 3 times 1/4 squared, which is 3/16. And g of 1/4 is 1 minus 1/4 squared, and that's 1 minus 1/16, which is 15/16. As we can see, g is greater than f. That means g is the above and f is the function below. Now we can integrate. We want to integrate from 0 to 1, but we have to pass through 1/2, and then the functions change their value. I mean, which one is above and which one is below. So to find the area, we need to find this area and then this area. The first area, area 1, is here. This is area 1, and this is area 2. So we need two integrals. One integral from 0 to 1/2, and the upper function is g of x, and the lower function is f of x, plus the other area, a2, from 1/2 to 1. The upper function is f of x, minus the lower function is g of x. Now we just plug these functions. G of x is 1 minus x squared, minus f of x. F of x is 3x squared dx, plus here from 1/2 to 1 we just reverse the order, 3x squared minus 1 minus x squared dx. Simplify more, 0 to 1/2, 1 minus x squared minus 3x squared minus 4x squared, plus integral from 1/2 to 1. We have negative here. This becomes 3x squared minus 1. We insert the negative sign, becomes 3x squared plus x squared is 4x squared minus 1 dx. Now we integrate. What is integral of 1? It's x. What is integral of 4x squared? 4x cubed over 3. And then we integrate from 0 to 1/2. plus what is the integral of 4x squared? It's 4x cubed over 3. What is the integral of negative 1? It's negative x from 1/2 to 1. Now we plug these values. Let's substitute 1/2 here. It's 1/2 minus 4/3 times 1/2 raised to the power 3 minus substitute 0, you get 0. This is the first integral. Plus the second integral, substitute 1, you get 4/3 minus 1, and then substitute 1/2, you get 4/3 times 1/2 cube minus 1/2. Now we simplify. We get here 1/2. This is 4/3 times 1/8, which is 4 over. We can simplify. This is 1. This is 2. That means we have 1/6. So 1/2 minus 1/6 plus. Here we have 4/3 minus 1, and here this is 1/8, and as we did before, this is 1/6, and this is now negative times negative is positive. So we multiply by 2, we get 8/6 minus 1 plus 1/2 is minus 1/2 minus 1/6. 8 minus 1 is 7/6 minus 1/2, and then we multiply by 3. I try to get the common denominator. These are just calculations. You can use the calculator to find this answer. So 7 minus 3 is 4/6, which is 2/3. So the second integral is 2/3. Now we multiply by 3 here. We have 3 minus 1 is 2/6 plus 2/3, which is 2/6 is 1/3 plus 2/3. That's 3/3, which is equal to 1. So the area is 1 unit. Now the last example. We want to find the area enclosed by y equals x squared and y equals x cubed. Now, in order to find it, we are not given the initial point, or I mean the bounds of the integral or limits of the integral from x equals what to x equals what. So in this case, it's better to graph the function. So we graph the function x squared. The graph of the function x squared looks like this. This is x squared. And now we graph the other function. The graph of the function y equals x cubed looks like this. As we can see, the area enclosed between them is this area, and this point here is 0. This point here is, we want to find this point. That means we set the two functions equal to each other, and then we bring this to the other side. It becomes negative x squared equals 0. Then we take x squared as a common factor. We get x minus 1 equals 0. Then either x squared equals 0 or x minus 1 equals 0. So if x squared is equal to 0, that means x equals 0, and that's the first point. Or x minus 1 is equal to 0, and that means x equals 1. That means this point is 1. Now what is the upper function? The upper function is x squared. So the area is the integral from 0 to 1. The upper function is x squared minus the lower function. The lower function is x cubed, and then the x. We integrate. This becomes x cubed over 3 minus x to the 4th over 4. From 0 to 1, substitute 1, you get 1/3 minus 1/4. Minus substitute 0, you get 0. So this is, now we cross multiply these or try to get common denominator. So we have 4/12 minus 3/12, which is 1/12.